I'd like to show a simple example of that now. So to create an entire circuit of cooling lines, what I have to do is start with a sketched path. So in this case, I'm going to add a basic loop through the mold in the top view. And in this case, too, we'll leave off the dimensions. That's just so we can get to see the end result quicker. So the preview on the screen is the cooling circuit. All we really need to do is edit the size of the hole we want. And also what I'd like to do is, let's take a look at the visual analysis here. What this will do is make a visual check for the cooling line collision. So what we're seeing on the screen now is actually an offset value that's being applied to the cooling channels. And any interference that's found at this level, it's going to show up as a bright red mark. So at 375, we're actually touching one of the pins. But really, this looks okay. So we're going to accept this whole circuit design. And it instantly does the cuts and the holes and all the components that are affected. I'm going to finish the discussion of cooling by once again going into the catalog area. All kinds of components like baffles and O-rings can be found in here. Cimatron has a very special ability for adding round parts like these. What we're able to do is add into a cone face, and it's very useful for tool design. The catalog component will position itself right at the end of the water lines, all over the place. This kind of intelligence, again, it really saves time over manually positioning all the parts that a mold will need to have. Well, as we've been designing and all this has been going on, Cimatron has been tracking all the work we've done. All of the new parts are found in a master bill of materials. And this is something that you can customize and set up. You can export it to drafting or maybe something more like Excel if you prefer. And while the mold design here isn't finished, the ordering of parts can begin. As can NC or electrode design or any of the other things that Cimatron can help you with. Those are other specialties that we don't have time to talk about in this session. At this point in the design, sadly, what usually happens right about now is that your customer decides to change the part. Engineering changes. They're a fact of life in the tooling industry. And so I'm going to end today by looking at how you can quickly incorporate changes to your part into the ongoing mold design. Now, changes have to be tracked. And so Cimatron can help by providing this handy little internal notepad. It's called ECO document. It's up to you how much detail you want to add here. You can add a description. Every EC is going to have a name. You can link to the new file. There's a click for adding pictures that will help describe. I have to find the right folder though. Okay? So when you've decided that that's enough in the ECO document, you can accept. Now, Cimatron actually provides two ways of implementing the changes. And that's why in the guide here, you're seeing two choices. One for updating the work file, or one for updating the cores and cavities directly. And we feel it's important to offer both choices. A Cimatron user can assess how vast a change really is and how much of the existing mold design is going to be affected. And that's really what's going to dictate which method you will use. I'm going to choose here to update my work part. So you will see that the system knows what data to be looked at. There we are. Because we've entered it in the ECO document. The new part now is being overlaid into the original part. Now this new data doesn't have the scaling for the shrink rate on it because it came right from your customer. But Cimatron even takes care of that for you. The system knows the shrink rate and it adds it. And the end result of this analysis is being shown on the screen here with a red and a blue display. The blue faces are the new ones, and they're going to be added into the project. The red faces are the old ones, and they're going to be removed from the project. And we end with the new data sitting in place of the old data. That will need to be distributed down farther into the cores and cavities. So we end up using, again, one of the first tools we looked at, which was Quick Split. We can edit the existing pull directions and have the system find and sort the new changed surfaces for us. Now, any real change to a part is bound to affect parting as well. This one is relatively easy, but still, we have an internal shutoff that's going to need redoing. And to solve it, I'm going to use the same functions I did before. And then update my core and cavity, and it will receive the new data. And I'm going to keep working on that, but I've really shown all the methods I was here today to show. So what I want to do is turn the session back over to Ralph and Lisa and see if you have any questions for us.
Yeah, thanks, Dan. Couple of comments to review what Dan has shown today. We showed about 50% of what the mold design product can do. We're trying to get through this and show as much functionality as possible. A couple of things to note. Basically, again, we don't have to use a perfect model. Dan went through this whole thing with doing the whole mold design, and he hasn't decided how he's going to do those two open windows on the one side. The flexibility of moving in the direction and how you want to work is a strong point with our software. The other thing to note, too, is there's no set order on how you go through the mold design. If you want to bring in your parts, lay out your parts, bring in a mold base at that time, you can do that. The same thing with the ejection and cooling. If you want to put the cooling in first and then put the ejection in, or if you want to put the ejection in and then the cooling, it's up to you. It's however you want to work. The nice thing about it is, you have to get it done, and we're giving you the tools to get it done. So, again, the flexibility and the automating of the process is to, your standards. One other note on it, too, as well, is the catalog components with the cutting objects. All of our catalog items have cutting objects, so it's going to fill in the place, the pocket or the clearance for the component you're adding. So a lot of flexibility, a lot of stuff we went through real quickly. So I think, Dan, you've gone through the engineering change?
It's going to calculate for a minute, Ralph.
Okay. Do we want to, let's go to the PowerPoint. Again, here's some of the highlights again. The flexible automated, design tools, working with any data. Some of the part analysis tools, as you can see, was set up for mold making, where you get the 2D projected area, the quick split, the standard and non-standard mold bases, runner, ejection, and cooling design, mold components, again, with the cutting objects, the ECO manager, everybody gets engineering changes. Again, Dan talked about full associativity through the whole process. He goes back and changes the layout, and somebody says the mold base is too big, we got to make it smaller. He can close those the layout up a little bit, and everything's going to update. And same thing with the drafting. We didn't get into any of the drafting or the electrodes or the NC. It's all full associativity and updates downstream. So a lot to the product and a lot to show in a short amount of time. We're going to go ahead and open it up for questions. Again, on screen you'll see how to submit some questions. Dan, do you have anything to add? Yeah, do you have anything to add before we get into the questions? Dan?
Do I? No, sorry. I don't.
Okay. All right. I'll read some of the questions that we have. Is it possible to do the same kind of thing but with a mirror part? Dan, I'll let you answer that one.
Yeah, absolutely. Well, mirror, we showed a little bit of it, and you saw that when I mirrored the surface, it was a copy. Mirror is something that we're working on right now because it's at a basic level of functionality. What mirror will do is always copy. It doesn't move. So if you've got an existing tool design and you want an entire mirror of it, it's going to take you a little bit because it can certainly pick the parts, mirror them over, and you'll have that copy. If it's two parts in one mold, then it's really not any different than what I was showing. Instead of the one part twice, you'd have the left on one side and the right on the other and work on them in that fashion. If they're true mirrors of each other, you don't even have to work on one. Just work on the other, work on the left, for example, and then when you're done, mirror it over and create the right.
Okay, thanks, Dan. Another question, too, will this work on family parts? Again, as Dan said, you load one part and then you load another part.
Yeah, that load work step, Ralph, as you know, we can have as many layout points as we want, and we can use load work as many times as we want. We have lots of customers doing family molds with Cimatron.
Another question here is, I've noticed that ejection